Good evening all. Today we are going to take a section on foundation recommendation based on soil investigation report. So before we enter into a session, can anyone tell me why foundations are so important? Anyone can please respond.
Resist the total load of a building.
Okay. Okay, thank you.
I think
So
it's better you just raise your hand and then respond. Otherwise, it will be difficult for noting down who is responding. Okay.
okay. Foundations are very important for a stable, durable, and steady structure. Foundations transfer all kinds of load from the structure to the ground. So there are various factors to be considered before designing any foundation, such such as type of structure, soil condition at that site, other surrounding structures, water table, etc. So this is one of the latest news which we have all come across. A crack has been found in the metro pillar. As per expert investigations, these cracks can be formed due to mainly two reasons, that is corrosion on the bearing or on any other mechanical part, or due to change in soil type at the base of the footing during the time of flood happened in Kochi. So this is one of a critical situation that have been occurred. If anything like this happened after construction, it is very difficult to have the repair work, and reconstruction will leads to very high cost. So the recovery will be very difficult. So before reaching such situations, some precautions have to be taken before, so that these situations may not rise in the future. So it is very important to design a foundation properly. And the first and the foremost step in construction is planning. So when it comes to foundation, soil investigation is one of the foremost important step. And for a soil investigation, there is a common step, that is standard penetration test has been conducted, and it has been taken as a common test for any soil investigation work. So standard penetration test is called an in situ testing method. It is very simple and inexpensive method. It is used to determine geotechnical properties of soil, identify the type, nature of the soil at various depth. So there is an hammer of 63.5 kg weighing freefold at 75 centimeter. SPTN value is the number of blows required by the hammer to penetrate last 30 centimeter depth of soil. So from this figure, it is been explained that a borehole is drilled to a desired depth, and a sampler is inserted into the ground by a help of hammer weighing 63.5 kg, falling freely from a depth of 750 mm. So the number of blows required for each 15 centimeter penetration is noted. Total number of blows required to penetrate last 30 centimeter is taken as an XPT value. So this XPT is a direct measurement of soil strength. Higher the N value we obtain, better the soil properties in that region is being found. So there are two types of samplers used for this test, that is a split spoon sampler or shell bit tubes. Split spoon sampler is used to collect disturbed samples, whereas shell bit tubes are used to collect undisturbed samples. Disturbed samples are usually used to determine soil type, classification, density, whereas undisturbed samples are used to determine the geotechnical properties. So this is the borehole detailed report we obtained after soil investigation, and this borehole detail will be more explained in detail in the further section. So moving to foundations. Foundations, we mainly have two types of foundations, shallow foundation and deep foundation. Shallow foundations are found near to the earth's surface, where the soils have high bearing capacity, whereas deep foundations are found embedded deep inside the ground and where the soil does not have enough bearing capacities at the surfaces. So shallow foundations again is classified into footing and raft, where footing can be classified into isolated, stripped or combined footing. So first we move to the isolated footing. Isolated footing, as the name says, it is provided under each column individually. It can be sloped, it can be stepped with rectangular, square or circular shape as per design requirement. So the maximum depth we give for a shallow footing is 3 meters. This is a picture depicting isolated footing and combined footing. So combined footings which can accommodate more than one columns. So in some cases, when isolated footings are provided, there is an individual footing overlap is found. So that can be avoided by providing a combined footing. Strip footing. Strip footing is known as wall footing or inverted T footing. It can be provided in long strips under RC walls or load-bearing masonry walls. Now moving to what is raft foundations. When a structure is vulnerable to high, heavy loading on weak, highly compressible soils, it can be subjected to differential settlement. So when the soil does not have enough capacity to hold, it is obviously a failure or it can collapse and the consequence will be very bad. So in such cases, we provide raft foundations or when the load acting on each columns or in case when load acting on each columns are different, we provide raft foundation so that it ensures there is an equal distribution of loads. So in deep foundations, deep foundations is also known as pile foundations. So as you have all seen what is a pile, so they are deep vertical load transferring membranes made of concrete, steel or timber. It can be used in cases when the top bearing capacity of soil is low or when tall structures are subjected to more horizontal or lateral loads. So pile foundation always help to resist axial and uplift forces. Now the pile foundations can be, deep foundations can be classified into friction pile, end pile or combined end bearing and friction pile. So friction pile is used when there is no hard strata available and when the capacity is driven from the skin friction. And whereas in end bearing piles are used when there is a hard strata available at bottom and the capacity is driven from the bearing capacity of underlying hard strata. Combined footing comprises of both friction and end bearing piles and the capacity is driven from both end bearing and skin friction. So one example of combined footing we are going to look next is under rimmed called as UR. UR can be single bulb, double or multiple bulbs. The major capacity driven in UR is from the skin friction. So as we provide bulb, the capacity increases. So the minimum depth including the bulb is 3.5 and bulb resist uplift forces and axial forces. More the bulb means more capacity. So in first case, there is only a single bulb be provided. In second case, there are two bulbs provided. And third case, there are more than two bulbs are provided. Now, moving to tractor border DMC piles. Tractor and DMCs are provided only when there is an art strata available at a considerable depth. And in this case, there is not presence of bulb. So there is only minimum depth is 3 meter. In the last case, there was a presence of bulb. So there was 3.5 meter. This is, it's called tractor board because the pile drilling ring mounted is on tractor. And the DMC is provided for mainly superstructures and the name it is being called DMC because the driving mechanism used is direct mud circulation. Because of that mechanism, it has been called as DMC piles. These are the tractor mounted. Now moving to the formulas used for our calculation to obtain a safe bearing capacity. According to IS 6403 shallow foundation, this formula I think all are being familiar. You might have studied in your geotechnical classes. This is the formula for deep foundation in sand and clay. And it comprises this equation as two parts. First part is end bearing part and then the rest is the friction part. Now, another major concern in construction before constructing foundation is liquefaction. And liquefaction, it happens in loose, cohesionless, saturated or partially saturated soils like loose fine sands or silty sand. So, like when the soil is subjected to heavy seismic vibrations or sudden changes in stress conditions or additional pore water pressure develops, in such cases, the shear strength of the soil becomes zero. So, it's act equally to like of a liquid and therefore it cannot take up any load and it collapses. So, in order to find if the soil is liquefiable or not, we go for the SPTN values as a measure. In the range of, if the SPTN values is in the range of 4 to 10, it's likely to liquefy. Um, we, the calculation can be found from IS 1893. And if the factor of safety is less than 1, then the soil is quite likely to liquefy. This is one example of the calculations obtained from our software. The FL we got here is 0.98, which is very less than 1. So hence it will liquefy. So in such cases, the soil can be improved by providing any soil improvement method. Mainly we consider, we have many kind of ground improvement methods. One of the main three common ground improvement methods are sand piling, removal of existing soil and filling, and compaction in layers. Other methods are stone column installation, hardcore layer replacement, or grouting. So sand piling is one of a common method. Initially, 50 dia piles are inserted and they are filled and compacted. And they are provided with, they are placed at equal spacing, that is 30 to 75 centimeter. Sand pilings act as a channel to drain water from the soil. So whatever water is there in the soil, they can drain the water from the soil, and which in turn resists the development of pore water pressure, and hence the soil get improved and the N value also get improved. So after doing all this, these are the some ground improvement method. There are more than these ground improvement methods. So once when the ground improvement methods are done, we have to ensure that if the N values are improved, so that to confirm the method is effective or not. Now moving to the second session will be taken by Kirti Miss. She'll be teaching you in detail about the soil report investigation.
Hello. Hi, good evening all. Am I audible?
Yes.
Hello. Am I audible?
Yes.
Is
Yes,
sharing is
Miss.
okay? Screen is
Yes,
visible?
Miss. It's visible.
Okay, as a continuation to what Steffi said, let's see some of the soil investigation reports. And from this soil investigation reports, how we will arrive a solution in recommending suitable foundations. So here I will show you some of the live soil investigation reports of live running projects. So this is how this is a sample of soil investigation report. I will show you basics of this report. So this is the first page, which consists of client name and the site where the soil investigation is done. Is this visible clearly? Or should I increase the size? Hello?
Hello.
Can somebody respond? Is it visible or should I increase the size? Is it
It's
visible?
visible.
Okay. So these are the basics, like client name, then site where the soil investigation is done, then period of investigation, and who are doing this investigation work. All such details are given. Then this is the introduction part. Then comes the scope of work, where from the start to end process is detailed. And then program of investigation, in which the field investigation, what all field investigations are done, like boring and sample collection. All these are described in the second part. Then come to the laboratory investigation part. What all laboratory tests are done for finding out the physical and engineering properties that are listed here. Then next is now coming to the next part. This is another next part of the report, which comprises of the borehole location plan, in which the borehole location is or the borehole position is mentioned here. Then coming to the next part, this is the major focus of our report, which shows the description of soil, that means the soil type and the depth, then showing the N values. So corresponding to each depth, what is the soil type and what is the N value, which is listed here. You can see. So this is how a soil investigation report will look like. And the last page, it consists of lab test report, in which you can see the soil classification is given here. Then its natural water content, bulk density, and Atterberg limits, grain size distribution, which means the composition of soil, and its engineering properties like specific gravity, cohesion, angle of internal friction. I think you all are familiar with the terms. These are the engineering properties which determines the soil strength and all. So all these properties we can get from various lab tests, and which is listed as a table here. So this is the major focus from which we through several calculations as per code, and then we get into a proper foundation recommendation. So let's see each different types of reports in which we have given different foundation recommendations. Let's see each one by one. So if you look into this particular report, the first 2 pages are lab test reports, and then moving to the next page, this is the bore log chart, in which you can see each soil layer and its N values are shown here. So if you look into the first soil layer, this is clay sand having very low N values, as Steffi said or Steffi mentioned in the last session. You can see here the top soil having very low N values, but at 2 meter depth, you can see this fine sand is having N value 50, which means it's really dense. As per IS classification, in case of sandy soil, from 0 to 4, the soil can be considered as very loose soil, and from 4 to 10, if the N values ranging between 4 to 10, it can be considered as loose sand. From 4 to 10, it is loose sand. From 10 to 25, it can be considered as medium dense, and from 25 to 40, it is dense, and above 40, it is very dense. So as you can see, the first soil layer is very loose and the second layer is very dense. So without doubt, we can provide an isolated footing at 2 meters. So there is no need of going for a deep foundation here. If you look the second borehole, you can see here also at 1 meter depth, we are having very loose sand, but at 2 meter and 3 meter depth, we are having a medium dense soil. So here also you can go for an isolated footing at 2 meter. Now, one of the major things that we have to keep in mind while recommending foundation is we have to go for multiple options if possible, because as we progress our work, or as we work on structural side, there can be possibilities of not getting the foundation recommendation. What we recommend at site, it may not be possible to carry out at site at some particular conditions, maybe because of water table level. We won't be able to construct isolated footing or shallow footing at site. So at that times, we will have to go for pile foundation. So in such cases, to avoid confusion, we have to give multiple options if possible. So here, as you can see, there are 2 options. Either we can go for a isolated footing at 2 meter, or we can go for a pile foundation, as we are getting a hard strata or it is present at 4-meter depth. So here, as you see the foundation recommendation, here you can see we are giving two solutions. First solution is an isolated footing at 2-meter depth, and second solution is a tractor board pile at 4.2-meter depth. So like that, if possible, multiple solutions we have to provide. So this is how a recommendation report will look like. It will be having the first page with some basic information like site, project, and client involved. Then the details of structure, what type of structure, number of stories that we have to mention to get an idea about the load coming on the structure. If it is a G+1 structure, it means a 2-story can be a residential building. So like that, we can have the idea about the load coming. And next is borehole details. Like the borehole description will be given. What all type of soil are coming at what depth and the N value variations that we will provide there. So by reading the borehole details itself, we can picturize this borehole chart. Now, the next part is recommendation, where we will provide the multiple feasible solutions possible at a particular site. Now, this is the calculation part. This is obtained from our software. We are giving all these calculations we are doing by using our softwares. So in software, we'll be using the calculation as per IS. This equation is already explained by Steffi. As per IS 6403, these bearing capacities are calculated. So two types of calculations are there: strength criteria calculation and settlement criteria calculation. So by calculating accordingly, we'll be giving the less value. The lesser of strength criteria and settlement criteria value is taken as the self-bearing capacity, and here the factor of safety considered is 3. So accordingly, here we will be giving the self-bearing capacity value for the isolated foundation. Now coming to the tractor board pile capacity, as Steffi mentioned in the earlier section, we'll be having two parts, confliction part and the end-bearing part. Here you can see confliction for each separate layer is calculated here, and the total safe friction capacity is calculated. Here it is just below 3 tons, that means 30 kilonewtons. And now you can see the when bearing capacity is coming nearly 19. That means much higher than the frictional part. So likewise, here also safe capacity is pile is calculated by taking factor of safety 3. Also, one more point I have to mention. In case of tractor board pile, we are adopting diameters 40, 45, and 50. Only up to 50 dia will be using in general. But in some cases, if the load coming is really high, we can use up to 80 centimeter dia piles also in case of tractor board pile. Now coming to the next report. Initial pages are the same, so I'm just skipping to the last part. So as you can see here, N values of plus 1 meter soil layer is really high, so it comes in the loose sand range. But from 2 meters up to 7.5 meters, we are having pretty good N values, which comes in the range of medium dense soil. So here we can give isolated footing or shallow foundation recommendation at 2 meter, and an optional next one we can give is a single UR recommendation, because here we can give underrimmed pile also, because here we are having sand with good N values. But you may think there is a possibility of giving UR at 3 meter, but it is not possible because the minimum depth requirement is 3.5 as the pile as the bulb formation is there. So we can go for a pile UR recommendation at 3.5 meter only. Even though there is a good soil at 3 meter, it's coming there. We cannot go for a pile recommendation at 3 meter. It's not possible at site. While working up, it won't be feasible. So while So we have to keep it in mind such conditions also. If you look the recommendation part, you can see here also we are giving multiple options like one for isolated footing. That means one for shallow footing and one for a deep footing, deep foundation. That is underrimmed pile. Here also we are giving capacities up to 50 diapile. In case of underrimmed pile, it's pretty difficult to go for a 60 centimeter diapile because the bulb formation is difficult for construction at site. It is difficult to form this bulb in a 60 centimeter diapile. So considering the construction easiness, we'll be providing only 40, 45 and 50 centimeter dia pile capacities only. These capacities are also safe capacities. And the calculations are also, it's the same as the underrimmed pile. There is also skin friction and end bearing friction component. Now coming to the next one, I'll be skipping the first part. These are lab test result part. If you look the bore low, is it visible? These values are visible. We'll zoom this. To look at the values, you can see these values are very low. It's coming in the soft soil range. It's also clay, so there can be a possibility of settlement in the soil. So here it is not possible to give shallow foundation. Even if we give a single underrimmed bulb pile, we won't get much capacity for the load coming to the soil. So there won't be a proper load transfer from the superstructure to the soil if we provide a single UR. So what will be the solution? We have to go for multiple bulbs. Like more the number of bulbs, more will be the capacity. So for that reason, we have to increase the number of piles. So for that, we'll be increasing the number of bulbs. So we'll be go for double bulb pipe here. That means we'll be constructing two piles at at particular intervals to get the capacity. Here you can see at 25 meter, we are getting medium dense to dense soil. Then why are we not recommending a DMC pile at 25 meter? Can anyone say? As Steffi said in the earlier session that if you have a good soil at the bottom or at the base, we can go for DMC or tractor pile. Then why we are not giving a pile recommendation for 25 meter here? As you can see the recommendation, here only we are giving a double bulb pile at 10 meter. Then why are we not going for a DMC at 25 meter? Can anyone say? Even if it is wrong, that's okay. I will explain you later. Can anybody say why we are restricting the length of pile to 10 meter or 12 meter? Why it is so? Why are we not going to 25? If we go up to 25 meter, we'll get much better capacity. As depth is increasing, capacity will be more. Even the end values are very high. Compared to 2, 25 is really big. Then why are we not going for greater depth? Can anybody say? Anyone raising their hands? Somebody please respond. Should I answer myself? Why are you not responding? Anybody please respond. Whatever you understood, you just say. Even if it is wrong, that's okay. Nobody's there. Okay, I will say myself. At 25 meter, it is okay to provide a DMC pile at 25 meter. There is no such restriction for that. But you just see the structure. it is just a two-story residential building. So there won't be much load coming on the structure itself. So if we look the column loads, it will be very less. So for such medium structure loads, it will be highly over-designed if we go for a 25-meter pile. Even for the mobilization, it costs nearly 50,000 rupees to construct a DMC at site. Even at 25-meter, the mobilization charge itself nearly cost up to 50,000. So who will be willing to take up that much charge or that much cost? So in cost-wise, it will not be reasonable. So that's why we are not going for 25-meter depth. But if the column load coming was really high, for example, if the structure was say G+3 or G+4 or some 5 or 6 story building, the load coming will be that much high. So in that case, we cannot compromise. There we will be going for a 25-meter DMC pile. So likewise, we have to compare the cost and the capacities of piles together. So that cost sense is always essential while doing this recommendation. So that's why I ask you why we are not going for a 25-meter. It's because of the cost sense coming. Now, if we look the calculation part, it's just similar to the single bulb under end pile calculation. We will be calculating skin friction at different depths, as you can see here. Here, the total skin friction capacity part is nearly 9 tons, where the end bearing capacity is coming just 7.6. So the major part of contribution is from the skin friction part, since it is a under end pile, because the end bearing will be really, because the base of the soil is here just 2, end value is just 2, so there will not be much end bearing capacity deriving there. So most of the capacity will be through skin friction part. The skin friction force is actually the adhesion force between the pile material and the soil, surrounding soil. That's we term it as skin friction. Now coming to the next report, it's all the same. First pages, introduction pages and all, it's all the same. If you look at this report, it is a residential apartment building having 11 stories. B plus T plus 10. It means ground floor plus 10 stories. So total 11 stories with basement. B denotes basement floor, cellar floor. So as you can see here, the load coming will be really high because it's a 11-story building. You can imagine a 11-story high-rise structure, how much load coming from the structure. So here, even though from the first soil layer, the soil N values are really high, like it's coming in the medium dense range, but the load coming is really high, pretty high, so that we cannot go for a UR or for a tractor board pile and all. So here we will be recommending a DMC pile itself. That's the only recommendation here we have to provide. If it was some 1 or 2 story building, maybe you can give a shallow foundation at 1 or 2 meter. That's possible. But here it is, since it is 11-story building, we have to go for 7.5 meter up to 7.5 meter, and the pile base have to rest at hard rock. And for increased capacity, we need to embed this pile base to the hard rock. So it has to extend to few meters into the hard rock for increased end bearing capacity. So here we have 2 boreholes. Here also there is hard rock. It's in 10.5 meter. In this soil strata, it is coming in 7.5, and here it is coming in 10.5. So as the depth, there is depth variation, there can be difference in capacities also. But as a common recommendation, we will be providing capacity of pile depth 7.5 meter only. So here you can see, we will be recommending only one possibilities only, because here the building or the apartment we are dealing with is of high load. It's 11-story building, so no other possibilities we are discussing here. Only DMC is the best possible and optimal solution here. So that's why only one solution. So in case of DMC pipe, we can have diameters from 50 to 100. Unlike what we seen in underrimmed or tractor board pile, where the maximum pile dia we can use was 50 centimeters or maximum up to 70 centimeters. But in case of DMC piles, we can use up to 1 meter. In case of some bridge structures and all, we can use up to 1.2 meter dia. That means 120 centimeter dia piles also we can use. Yeah. And the calculation part is also just the same. And one difference is here also we'll be calculating skin friction and end bearing part. But you can see the skin friction capacity is coming just 9.5, means nearly 10 tons. But the end bearing capacity here is nearly 60 tons, near to 6 times, because DMC piles derives its major capacity from the end bearing part or from the point bearing of the rock strata. So here the end bearing capacity is multiples or 6 times higher than the safe bearing capacity of derived from frictional part or the skin friction part. So that's how we are doing calculations in our software and will be arriving at different possible solutions of foundation recommendation. These are some examples that you can see here. These all are live running projects for which we have given our best possible solutions of recommendations. That's all. Thank you for listening.